Experiment. The aim of this experiment is to determine the acceleration due to gravity g by a simple pendulum. Materials and the apparatus: retort stand, meter rule, 1.5 meters thread, pendulum bob, and the stopwatch. Procedures. Number 1. Set the apparatus as shown in the figure below. Number 2. Hang the pendulum bob on one end of a 100 centimeters length of thread. (100 centimeters). Number 3. Let the pendulum bob dangle over the edge of the bench. Number 4. Give a pendulum bob a small displacement. Release it and it will begin to swing. Give it a 20 complete oscillations and record the time. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Therefore, the time for 20 complete oscillations is 40.65 seconds. Number 5. Repeat the above procedure for values of 80 centimeters, 60 centimeters, 40 centimeters, and 20 centimeters. Table of results. Length of thread in centimeters. Time for 20 oscillations in seconds. Time period in seconds. Time period square in second square. For 100 centimeters. Time for 20 oscillations is 40.65 seconds. Time period for one oscillation is equal to 40.65 seconds divided by 20 oscillations, which is equal to 2.033 seconds. Then time period square is equal to 2.033 square, which is equal to 4.13 second square for 80 centimeters. Eighty centimeters. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 36.72 seconds. Time period for one oscillation is equal to 36.72 seconds divided by 20 oscillations, which is equal to 1.836 seconds. Then time period square is equal to 1.836 square, which is equal to 3.37 second square for 60 centimeters. centimeters. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 31.87 seconds. Time period for one oscillation is equal to 31.87 seconds divided by 20 oscillations, which is equal to 1.594 seconds. Then time period square is equal to 1.594 square, which is equal to 2.54 second square for 40 centimeters. centimeters. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 26.81 seconds. Time period for one oscillation is equal to 26.81 seconds divided by 20 oscillations, which is equal to 1.341 seconds. Then time period square is equal to 1.341 square, which is equal to 1.80 second square, and for 20 centimeters. 20 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 19.59 seconds. Time period for one oscillation is equal to 19.59 seconds divided by 20 oscillations, which is equal to 0.980 seconds. Then time period square is equal to 0.980 square, which is equal to 0.96 second square. Graph of L against T square. A graph of L against T square. Scale. Vertical scale 1 centimeter represents 5 centimeters. Horizontal scale 1 centimeter represents 0.40 second square. Length in centimeters. Time period square in second square. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. 0.40, 0.80, 1.20, 1.60, 2.00, 2.40, 2.80, 3.20, 3.60, 4.00, 4.40. For 100 centimeters to 4.13 second square. For 80 centimeters to 3.37 second square. For 60 centimeters to 2.54 second square. For 40 centimeters to 1.80 second square. And for 20 centimeters to 0.96 second square. A graph of L against T square. Slope of the graph. Slope is equal to change in L over change in T square. 1.40, 30. 3.88, 30. 3.88,95. Slope is equal to 95 centimeters minus 30 centimeters over 3.88 second square minus 1.40 second square, which is equal to 65 centimeters over 2.48 second square, which is equal to 26.2 centimeters per second square, which is equal to 0.262 meter per second square. Therefore, slope is 0.262 meter per second square. Determination of the acceleration due to gravity g. By using this formula, t is equal to 2 pi the square root of L over g, square on both sides. Then t square is equal to 4 pi square L over g. Make L the subject of the formula. Then L is equal to gt square over 4 pi square. By comparing with the equation of a straight line, y is equal to mx plus c. Then slope is equal to g over 4 pi square. Make g the subject of the formula. Then g is equal to slope times 4 pi square, which is equal to 0.262 meter per second square times 4 times 3.14 square, which is equal to 10.34 meters per second square, which is approximately to 10 meters per second square. The acceleration due to gravity g is 10 meters per second square. Sources of errors: air resistance, wrong counting of the number of oscillations, bad timing of the stopwatch, and the inaccurate measurements of thread. Precautions: number of oscillations should be counted correctly. Time for oscillations should be measured correctly, and the length of the thread should be measured accurately.